Welcome, everyone. My name is Mike Kotsur. I am originally from Ukraine, so my real name is Mikhailo. But currently I live in the Netherlands, and I would like to tell you about my experience with Functional Scala, and particularly my experience with building software prototypes. A little bit about myself. So I have been writing code for already quite a lot of time, for like 10 or 11, 12 years even. And like I'm not going to tell that much about my experience. If you're interested, you can check out my Twitter. There is a special thread. So if you download slides and click on this link, you can read a little bit about that. And so personally, what makes me very happy is either hiking up in the mountains or writing some good code. And well, it's now a very difficult time for hiking in the mountains, so I have to do with writing some functional code, which is good. And I've been doing this in my current project, and this gave me some really good moments, and some moments were not so good. But in any case, I learned a lot, and in this talk, in this next 40 minutes, I'm going to talk about like what prototyping is about. Very briefly tell about the project itself, like which problem it solves, and also we will go through 9, I think the final count is 9 lessons, which I want to share with you. And some lessons are a little bit shorter, some of them are a little bit longer. So it begins with some abstract things, and at the end there are some short, very to the point, like almost recommendations kind of lessons. And in the end we will try to make a conclusion and see whether Functional Scala is actually a good tool for building proofs of concepts. So what is actually software prototyping? And I guess it's not a hard science, and there are many definitions around and out there. And like my at least understanding and understanding of some people that I discussed it with is that software prototyping, it's testing a business idea with a minimal functionality. And like when a company wants to roll out a new product, for example, they want to see whether there is a market for this product, and they want to find a market fit. And they do it by building something small, showing it to potential customers and asking what they think about it, and basically trying to make the next iteration, which makes them possibly think a little bit better about this prototype. And in the end, by following these small iterations, you should have a pretty good understanding of whether, first of all, whether people need your thing that you're building, and second, whether like how exactly you want to build it, because there is an infinite amount of possibilities of how you can build something. And for us, for techies, for technical people, it's often a little bit tricky, because there is a big shift towards building things quickly and not spending too much money on development, because it's just a prototype, so it's not delivering any money to the company. So yeah, why spend a lot of efforts in that? But at the same time, it's important to keep in mind that the quality of this prototype is also very important, because if you show to people something that doesn't quite work, then it's difficult to get the feedback if they can't like properly use it or understand how to use it. So it's basically, it seems like a classical dilemma. And I joined this data exchange project. So the name of the project is Data Exchange. And so the main idea is the following. So there are some companies that have a lot of data, like banks, insurance companies, hospitals, and there are researchers that either independent researchers or that work in universities, and they want to do some analysis of this data for various reasons. And like ideally, in the ideal world, the data would just go from people who have data to people who need this data for research. But unfortunately, it doesn't quite work like that because the data contains a lot of sensitive information. And yeah, well, we will not go into the details about that, but basically there is a trust issue or also legal issues, but also mainly trust issues that, yeah, the data providers are responsible for storing this data security, so they need some sort of, well, as much as possible guarantees that this data will not be compromised. And this is where the company comes in, which hired me to build a prototype of a system which could possibly facilitate the data exchange between the data providers and the researchers, which would happen in such a way that the data wouldn't be technically possible to leak the data. And the idea that there would be some secure container and the data will be fetched into this container, and the researchers will also submit an algorithm into this secure container, and something will happen, then the result will come out of this container, the data provider will take a look at this result, and then when they see that there is no confidential data in this result, maybe it's some graphs or maybe it's some aggregated numbers, then the data can be released to the researcher. And this project sounded really interesting to me because it solves some real issues that happen every day in the modern world. So the name of the company is Surf, and there is a link where you can read more about this project. It's a Dutch company, but this link leads to an English page, which you can read. So I joined the team, and there were some developers working on this team already, who mostly worked with Python and the front-end technology called Svelte. And we started thinking about, and the project was in a very, very early phase, like almost no code was committed. And we started thinking about, like, okay, how should we build it? And basically, the idea was first to use only Django for this, but we quickly realized that you basically need some asynchronicity in the system, because if you just build it as a normal flow, a single thread application where you just do things and wait for them, then it will not be usable, because executing algorithms takes time, especially if you take more or less serious data sets. But not even then, our goal was to take the scripts, the Python scripts in our case, of the researchers, and we would also install the dependencies of these scripts so that they could run, so that those scripts could use some Python libraries for processing the data. And installing Python dependencies definitely takes a lot of time. So yeah, so basically the solution was to introduce some asynchrony into the system using a RabbitMQ and creating a component which was called Tasker, and which would be written in Scala. And that component would basically pick up all the slow operations, like working with Docker host and stuff like that. So yeah, and the thing is that I had to develop this component, and prior to this project, I didn't have that much experience with like hardcore functional programming. I had a lot of experience with akka and actors though, and some experience with reactive streams. Not that much. So there was a very difficult choice for me, the point where I had to decide, okay, whether I go with a technology which I know really well, and I'm pretty sure I can I can quickly develop in, or should I try functional programming? And the risk, of course, was that if I get stuck with something, then there will be people who will be waiting for me solving these problems, which is obviously not nice when you work in a team. So how I solved it, I did some pet projects with functional programming, and I thought, well, okay, maybe it's I'm confident enough to try. And I learned a bunch of lessons during this project, and I'm going to share them. And the first lesson was that if you are into functional programming, then future is actually a thing of the past, and you don't really want to use future. And it's interesting because actually future is a very useful thing. So if you have a future, so the first thing that future does, it protects the value which is inside of this future from being accessed too early. So you can't say times 2 f0 because f0 is a future, it's not just an integer. So if you think about it, then this distinction is possible only because you have the future type, which is very nice. And future also gives you a lot of special functions which you can use to access this data, which is also nice. What is not so nice about future, though, is that future is evaluated eagerly. So when you start a future, when you apply the future type, when you use the apply method, then the future is started immediately, or the computation is started immediately. And if you want to do some refactoring, then it becomes tricky, because you may think that those two pieces of code are equivalent, but actually they are not. And this is a very popular example. It's yeah, if you Google for plot problems with Scala futures, you will probably see it. And the difference, of course, that in the top piece of code, the futures are actually started in parallel if you're using proper executors. And in the bottom piece of code, the second future will start only when the first future completes, and that is because of the for statement, which uses flat map, and flat map is sequential in monads. And also, if you try to do some high-level optimizations of your program, like for instance, you try to model some activity, and the activities have name, price, importance, and well, the activity itself. And if you model it as a future, you will not be able to do something like do cheap first, do important first, because well, when you create this list, your activities will already be started. And of course, you can work around this by wrapping a future into a function, but that makes things just too complex, or much more complex than they should be. And so if future is a thing of the past, and if we are not supposed to use future in functional programming, what should we use then? And because functional programming is, people are a little bit afraid of it because it has so many different things in it, and that's true. But actually, what I also learned, that functional programming is not all or nothing. So as long as you start with functional programming and you learn some very basic concepts of it, you can improve your coding very, very significantly. And in this lesson, I'm going to share the most important piece of functional programming, or the cornerstone of functional programming. And not surprisingly, it's about functions. So in mathematics, functions are relations between sets that associate to every element of a first set exactly one element of the second set. And well, okay, this sounds fine, and you may think, okay, what's the connection with the programming? And the connection is the following. So you can easily encode this example in Scala using sealed traits and case objects. And then of course you also have a definition of a pure function in computer science, and it's basically equivalent more or less to the definition in mathematics, and it says that the return value should be the same for the same arguments, and the evaluation of the function should not have side effects. So okay, fine. And if you think a little bit more about the definition, the mathematical definition of the function, where it said that every element of the set should be mapped into an element of the other set, and then you think, okay, there is an example of a function. It's 1 divided by x, and well, there is an element of a set of rational numbers which is 0, and this 0 is not mapped to anything. It basically doesn't have any value in this function. And well, mathematicians would say that this is actually fine, because you are pretty flexible in what you define as the input of your function, which is called domain, and the output of your function, which is actually called codomain. So, and that is really similar to what we have in programming, because like what can go into a function, and this is the first set, is called domain, and what can possibly go out of the function is a codomain, which is the second set. And in the case of the function 1 divided by x, we deal with the domain, which is not the whole set of rational numbers, but a set of rational numbers without 0. And the codomain is the set of rational numbers also without 0. And if you think deeper about this definition, it actually becomes very obvious why function 1, or Scala function, is defined as covariant with regards to T1 and contravariant with regards to T1 and covariant with regards to R. And that is because it's okay to handle more possible values that you actually declare. Well, it definitely doesn't break. It makes it a little bit more difficult to use the function, but it definitely doesn't hurt. And it's okay to define the return type as a larger set. So, well, that's just an example of how sets theory is related to what we use every day in programming, and why it's useful to learn some basics of functions in mathematics. But you can also look at this in a very practical manner. So we use, let's take for this function, for example, get username, which takes some sort of user identifier and returns you a username. So you can write this function, and many people actually do write this function as a function of string to string. And this function is definitely not pure. And this is because if you think in terms of sets, it's definitely not true that for every string you get a username, which is also a string. There are some usernames that don't have any users associated with them, right? So to make it a little bit more pure, what we do, we wrap it into an option, and then basically we say that it returns a string or nothing. And to make it even more pure, because actually we know that our function is not, it doesn't take the users from its body. So it needs to go to some database for those users, and the database may not be available, and so on. So basically we end up with using a try. And basically we tell that it can be either a string or nothing, or some subtype of throwable. And if we want to be really, really fair, and we use some asynchronous programming, we also need to say that actually this function will return you something, but the result will not be available immediately. So it's also so you also need to somehow say that this is a future or something which you can't immediately access. And this brings us to the definition of a functional effect. And I like the definition by John DeGauss because it's pretty like practical. It also give you some hints about like how you can implement functional effects. And it says that a functional effect is an immutable data type that describes the computation of one or more values where the computation may require an additional feature like optionality, login, access to context, blah, 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 blah. And using effect-specific operations, functional effects can be transformed. And to deal with functional effects, you have a special type of libraries which are called effect systems. And an effect system basically is something that tracks effects and classifies them perhaps into different types of effects and adds them to the type so that you, the compiler can check that you are doing the right things with those effects. And Java, for example, has a very, very restricted and limited effect system, which is called exceptions, checked exceptions. Right. So I will give you some examples with Cats effect. And Cats effect is basically an effect system which has some certain data types. And if you are not familiar with Cats, or if you are familiar with Cats, and Cats effect is it can be seen as a much more higher level library than Cats. So we will take a look at those data types which are on the picture, mostly I/O and resource. So far so good. Lesson 3. And lesson 3 is about the I/O data type from the Cats effect library. And particularly, I have realized that this data type is very convenient for evolutionary development, and like other effect types as well. And the whole concept of effects is useful, but I will illustrate this with the I/O type. So when you build prototypes or proof of concepts, you don't want to spend a lot of time reinventing the wheel. So you may want to use libraries, specifically Java libraries, that not necessarily are suitable for functional programming. So most likely they are not, because they're Java libraries. But there are a lot of Java libraries out there that are just useful because they just do the job done, and you still want to integrate them into your program in some good way, right? So, and I will show an example how to do it with the I/O monad. So let's say you have a method from some Java library which is called Java Gamble, and it returns you either an object or it throws an exception. So two possibilities basically. And yeah, and what you want to do is you want to write your application using the I/O monad, which is like the cornerstone of the Cats effect actually. So you define your program as an I/O, and you do it by wrapping. So one of the ways to create this I/O data types is to wrap some computations into some constructor of this I/O data type, and in the very generic case, it's basically passing some continuation into the I/O. We'll just store it inside an I/O data type. So you will not see how exactly it's stored, but if you, for instance, execute this and open the debugger, for instance, or maybe also read the code of the I/O apply method, you will see that your code which you pass into the I/O is not executed immediately, and instead of that, it's just stored in another case class which is called delay. And there are several different case classes inside the I/O inside of Cats effect that kind of store computations, and they don't execute them. But they need to be executed because your program needs to be executed, right? So what Cats effect does instead, it lets you build this program, describe this program in terms of this computation stored inside the I/O, and classified. Like in this case, it's wrapped into a type delay, but there are different types to describe synchronous and asynchronous computations. And when you return something from the run method, which will be also wrapped into an IO, the FX system will unwrap the code at the end of the world, or at the place which is not accessible to you as a developer, but it's a part of the framework. So you don't basically need to care about the actual execution of your program. So what will happen when we run this? And we can actually compose those computations with flatmap because IO is a monad. So what will happen when we run this is that perhaps there will be an exception because, well, we know that there are a lot of chances that this method throws an exception. But the exception will actually not be thrown from the line which is currently highlighted. In the end, the happy flow of the monad will be interrupted, and the value returned from the run method will be an unsuccessful value of the monad, which is already, somewhat better than just throwing an exception, which is definitely not pure. And this trick allows you to deal with impure code like if it was pure, by wrapping it into an IO and moving on. But it also gives you some extra possibilities. And let's imagine that we don't want to throw an exception. We want to handle this exception. And for that, we can use special functions. Like, remember from the definition, it also has functions to deal with the effects. And those functions are called combinators. And in this case, we will use a combinator attempt, which can convert your exception into an option. So in this scenario, we will always get a result, which may contain none or may contain some, but there will always be a result and there will be no exceptions at all. Or we may want to do something different, actually, which is retry until we get the jackpot. And it's also quite easy to implement with Katz effect. And because of the lazy nature of everything and descriptive nature of computations, you can retry by just doing a flat map. And that works safely because Katz effect employs a technique which is called stack trampolining, which allows you to do flat map without taking care of recursion or tail recursion. So this is how you retry your computation until you're out of attempts. And there is also a library which works with the IO monad, which is called Katz retry, if you want something more fancy like exponential backoff or something like that. So you may also want to run your method in parallel. And this is also easy. And if you think about it, this is only easy because you have the description of your computation, so you can do all these kinds of things. So in this case, we can use the function which is called parsequence, and it will take a list of IO. So like you basically like list of computations, and it will run them synchronously, and it will track their progress, and it will give you one combined IO, which will finish when all computations are finished. Right. So in this sense, functional programming is actually very useful, and it's really good for evolutionary development. I don't know if you noticed, but basically we are always changing, like adding new features to your code by just adding something you don't have to go and rewrite something. You don't have to change the previous code. You just use combinators to add some new features to your code. And this is really useful because it means that you can add those non-functional features as you go. So you don't have to think about all of them in advance. All right, let's move to the next lesson, and this is about keeping your configs pure. And specifically, we will talk about the library which is called PureConfig, which I also used in this project. And like when you think about configuration and some static values in your program, there are different approaches. Of course, you can start by hard coding values, and then you quickly realize that hard coding doesn't work. So you need to extract them into a separate object, maybe with some values or lazy values or whatever, so that at least it's not in your business logic. But in fact, what you really want, like in the top example, but in fact, what you really want is you want to extract it into a configuration file, because it gives you this nice way of overriding the values. And PureConfig works with type-safe config format, which is called HOCOM, and it allows you to do basically everything what you can do with type-safe config, but in a nice and pure manner. So particularly what it does, so if you look at this piece of this piece of code, it just takes it and parses it into this case classes. And parsing it into the case classes has a really nice effect that your config is also validated at once. So you can describe, so here I use, so the structure here is pretty simple, but the structure can be also pretty complex. And it's really good if you can start your program and validate it. And also PureConfig, so in this example, let's go through this piece of code. So we have the two case classes, and we also have a method called hint, which basically tells that you want to use a camel case rather than snake case in the configuration values. And also you have the method loadf, which, well, you define yourself, and it tells where to find your config actually. So that it takes the default file, which is usually named reference.conf, and it searches in the root, which is called watcher, and then it loads it into an IO monad. And in this sense, it clicks really nicely with the rest of your program, which is also built with using the IO monad. And if you have several modules, you can also nicely organize configuration files in those modules. And let's say if you want to load them, you can load them sequentially, so that first it loads one configuration file, completely validates it, and if the configuration is wrong, for instance, some environment variable is not set, it will just blow up and tell you which variable is not there. So it's like really nice. Lesson 5, at least 2 thread pools. So here I want to talk about concurrency and parallelism, and particularly because you have these nice combinators in Katz effect, you tend to use concurrency, well, mostly parallelism actually, a little bit more than usually, than you would probably use with future, because it's so simple. But at the same time, when you use these powers, you want to be at least aware of how exactly it executes, because concurrency is a tricky thing. It's very environment dependent. It may work one way on your development machine and a slightly different way in your Docker environment or wherever you deploy your application. So let's go through the code. So the first block is about future, and we know that when we start a future, we need to pass the execution context, and the execution context is something that defines how your application will be run. And in case of IO, it works like almost the same way, except that instead of execution context, you need to pass a context shift, which is also sort of execution context wrapped into a case class. And normally, you should try to make your code non-blocking, and you should use the context shift, which is provided as an implicit parameter from the I/O app. Well, this is a default setting, and if your code doesn't block at all, or like never, you don't have anything to worry about. But in case your code blocks, you have blocking operation, you have to use a different thing, which is called blocker. And blocker is just a way to distinguish. So because blocker, essentially, this is also just a wrapper around the execution context. But you want to distinguish those two because you don't want to mix them. So as a rule of thumb, you should use, for asynchronous code, which doesn't block, you can use a fixed thread pool with a small amount of threads. And this is because your code runs so quickly, because it doesn't block, that it will not hold threads for a very long amount of time, and you're just fine with using a small amount of threads. So on the other hand, when your code does block, if your code needs to block, then you need to create a cached unbounded thread pool, for instance. Well, there are many types of them, but basically the main idea that your code should have the ability to produce new threads, because if it blocks and if it cannot produce new threads and you still want to run things concurrently, then you have an issue because you will have a deadlock. And in Cat's effect, as I said, you can use a special type blocker to write the execution context and configure it in the way which you want. So if you don't do that, then you're risking that the blocking tasks cause a deadlock, and otherwise, if you mix them the other way around, that the asynchronous code will create so many threads that your program will basically be out of memory. And well, you can read more about them, but yeah, well, the lesson is, at least 2 thread pools, you need to keep in mind when to use which. So lesson 6 is a very short one, and it's about unrecoverable errors. So we saw all these techniques to deal with the errors, converting I/O from errors into options, for instance. And sometimes you want that, but sometimes it's actually fine to not do that and let your program crash as soon as possible. So particularly it's useful when you validate configuration files, because if your configuration is not correct, then probably your program is not going to do really well, and it's probably easier if it crashes immediately rather than starts working and then crashes later, and you need to discover why it crashed and when and stuff like that. In this project, the case when we wanted to crash really early was if there should be a special Docker image on the host, download it and prepare it, and if this image wasn't there, then it didn't make sense to continue to run the program, for example. So yeah, just make sure that you distinguish between recoverable and unrecoverable errors. So lesson 7 is a quite interesting one, and it's about data modeling. So data model can make your life really easier than it would be without data modeling. So in this example, I have because I dealt with data and Python scripts which I had to download. I had to deal with a lot of different paths. I had to download them, and because it was in Docker, I had to keep track of paths inside the container and outside the contractor's container. So it was quite a mess. It would be quite a mess if I didn't model the data in such a way that I would use I would classify those paths by their meaning, and by using types, I would ensure that I can't use the wrong path in the wrong in the wrong place. make a legal state unrepresentable. And this is a very important lesson. And actually, FX system do really good job with helping you with doing that. So if you look at this type, which is called resource, it's actually very useful because when you create a resource, you immediately need to define two methods: acquire and release. And because you have to define these methods, your resource is kind of complete. It contains information about how to acquire something and how to release something. You can't create a resource without it. And when you use a resource, there is a very specific place where you can use it, and it's exactly between the acquire and release. So you have like a compile time guarantee that your resource will be used properly and it will be released in the end. And there is a example. So I have to speed up a little bit. So there is an example of where I used it, and I used it to define the container environment. So a container environment consisted of many different stuff. So I had to download the algorithm, I had to download the data, and I had to prepare some directories for output data. And it appeared to be that it's quite convenient to wrap this all into a resource. And you can start defining a resource using the method which is called eval-map. So you start with a temporary directory, then you add some stuff to it and download stuff. And if at least one of these operations fail, then the outer part of your resource will be automatically released. And this also ensures that I cannot use the container environment, so this type, because I created only inside the resource, I cannot use it anywhere else in the program. And it ensures that the data which is inside of this container environment is actually up to date, and those directories actually exist in the file system. And finally, the last lesson is about module sandwiching. So this is a very simple technique which I used to avoid creating too many microservices, yet being able to split my code into the modules. So because I/O is a type which can contain the whole program basically in one object, you can make use of it and start your programs as different fibers. And this is yet another data type. I can't unfortunately go too much into the details about this, but basically this piece of code starts several programs in parallel, and it also looks really nice, and it's really easy to run it in the development environment. I've been also running it in our staging environment without any problems. And an alternative to this, of course, would be to run app1 and app2 in different containers, which would be much more costly in terms of deployment and configuration. So just to summarize, basically the main idea which I tried to explain was that there are many ways how you can do better than just using features in Scala. And by knowing the basic principles of functional programming and using an effects system concept, you can beat it very easily. And that is by tracking effects. And effects help you to go fast without creating huge piles of technical debt, because there are less chances that your program will end up in an illegal state which doesn't know how to deal with. And by separating the data and behavior, you can ensure that you can change one without touching another, because in different phases of your project, you may want sometimes to change the data model, and sometimes you want to change the behavior of your program. And if you model your data in the sealed trait hierarchies and abstract data types, and you can do it easily. And in general, Scala ecosystem is great for prototyping. So yeah, I didn't have time to dive into the FS2 library, which is a streaming library, and that's a pity because it's really nice. I used it in this project really well. And yeah, if you have any questions, I will be happy to answer them. Thank you very much for listening, and yeah, the slides are available in my GitHub, and also there is a readme.md with some links to the articles and some resources which I used to prepare this presentation. Thank you very much.